Yeah, Nuwan,
Hello, sir.
Nuwan, if you don't mind, Nuwan, if you don't mind, and of course, I'm a friend of you. I have been a friend of you for a long time, but most of my students don't know who you are and where are you from and what subject you are expert in. So, could you please
Okay.
introduce yourself?
Right. Okay. So I think for both of us, like the same time. So good evening, dear children. So I am Nuwan Disanayaka from Sri Lanka. I am a school teacher. I work as a teacher in chemistry. I hope like you can understand me really well. If you can't like speak in English, तो हमको हिंदी भी आता है. तो थोड़ा थोड़ा हिंदी आता है. So आपको like जो बोलने चाहता है, you can हिंदी भी बोल सकता हो. So no problem at all.
Nuwan, for your kind information, we are all poor in Hindi.
My goodness, you are like really good in Tamil. You speak Tamil there.
Yeah, we speak Telugu.
Telugu. Okay, so
Yeah.
then it's fine. So I can't speak Telugu, but like if you have any doubts, I think your teacher will translate for me. So I'm going to like sort your doubts. I tried my best. So sort your doubts. So I'm from like in Sri Lanka in the middle. I'm in middle. It's called Kandy. So when you come visit Sri Lanka, is the middle of the it's a hill. It's called like hill country in the middle. So that's all about me. So let's see. Today's session will be an interesting one.
Very good. So, Nirja, try to introduce yourself and ask your question quickly because every
Hello,
second is
sir.
precious.
I'm
Here.
Neeraja. I'm studying 9th grade. My hobbies are playing games and watching TV. My future ambition is to become a nurse. I want to ask a question, sir. What will happen if pH value in our body increase?
Right. Okay. So I'll give you the answer, Hari Krishna, right?
Yeah.
Okay. Okay. So can I share my screen? Can you allow me to like share my screen?
You can do it now.
All right. Okay. I'll share it now. Right. Okay. This is the answer for your question. I just prepared a little bit of slides so that will make it easy. So you're asking what will happen if the pH value of our body changes. So that's yeah. Okay. Right. So your question is dual, like we call it. Sometimes I might call it dual, right? Dual means like it's dot, right? In Sri Lanka, right? So okay, so this is the dot. What happens? Says what will happen now? Your question is what will happen if pH value in our body increases? Now this is the thing. Now let's assume now you are eating, right? I think you might had your lunch, not dinner yet. So if you have your lunch, let's assume now you might have problem how it like decompose, how it digests. So the problem is how this food that you eat break into pieces and absorb the energy in that food into your body. So let's assume for this one to make it easy in your body, there's a chemical substance that called enzymes. Enzymes are the ones who make it faster. For an example, now if you have your lunch, by next day lunch, all the things that you have eaten is like digested. So it digests and absorbs to your body. So what will happen if you don't have enzymes? Because the help of these enzymes. Now, if you don't have these enzymes, what will happen? They have estimated. So it's called UNC study in biochemistry and biophysics. They have done this study. What will happen if there's no bacteria, no enzymes in the world? What will happen to the lunch that you eat? They have found that it will digest, and to digest, it will take 2.3 billion years. So it will digest. So that means if you eat today, so your food will be digested by 2.3 billion years. You don't have that much time. So therefore, what you have is something called enzyme. Enzyme is like something like this. Let's assume your target is the lunch you eat. This is your lunch. This is your lunch. The lunch you ate, it should break into pieces. To break into pieces, they have something called this enzyme. This is enzyme. So what like it's a molecule. It takes the lunch molecule in whatever the food you eat. It might be a burger or something else. Then it will break into pieces. Without this enzyme, it takes 2.3 billion years. Now let's assume what will happen if the pH value changes. They have found that if the pH value changes in our body, it will damage. It will damage our enzyme. So this is the normal enzyme. When the pH value changes, you can see that the enzyme get damaged. We call it denature. If it is denatured, now what will happen? again you need 2.3 billion years to digest your food, which means you won't, even you eat, you won't get the food into your body. So what will happen? Ultimately, you will die. That's what will happen if the pH in our body increases. Now, Nirja, is it clear, daughter? Did you get the answer for your question?
Yes, sir.
Okay, okay. Then next question.
Okay,
What's the
Lohita,
next?
Lohita, your turn.
Yes, sir. Hello, sir. How are you?
I'm doing well, though. How are you?
Fine, sir. My name is Lohita Girja. I'm studying 7th grade. My hobbies are reading books, playing games, watching TV, and dance. My life ambition is to become an English teacher. Can I ask one question, sir?
Yes, yes. What is your question, though?
Why carbon cannot form ionic bond?
That's a good question. Why carbon cannot form ionic bond? Let's see how we can answer that one. So for that one, I have to go a little bit right. Now, this is the next thing. Now, let's assume that you are going to buy a burger. Now, let's take in your school, the canteen, the tuck shop, or some call it cafeteria, they are going to sell burgers. Let's assume that the one burger is 10 rupees. So we have Nirja and Lolita. Okay, let's take now two friends, right? So let's take, there are two friends. Let's take he's Rajesh and he's, let's say he's Shankar. Now there are two friends. Now what will happen? Rajesh has 9 rupees and he need only 1 more rupee to buy the burger. But Shankar has only 1 rupee. So obviously Shankar finds that I don't need this rupee because I can't do anything with that rupee. So he said, I'll give you at 1 rupee because I can't do anything with it. So obviously Shankar will give his 1 rupee to Rajesh because Rajesh can buy the burger. But let's assume a search situation like this. Now Rajesh also has 5 rupees and Shankar also has 5 rupees. This one, Rajesh need 5 rupees more to buy the burger. Shankar also needs 5 rupees more to buy the burger. So obviously the Rajesh now, in this case, Shankar won't give his 5 rupees to Rajesh because if both are lack of 5 rupees, both of them. So like both feel that I can go for that 10 rupees and buy the burger. So the best suggestion the Shankar will come up with is, I'll also have 5 rupees. Let's buy one and share. I'll give you my 5 rupees, take your 5 rupees, we'll have 10 rupees. Now we'll buy one burger and they'll share. Same way, most of the atoms, they like to have completely filled outer shell. You know that if you take an atom, they have nucleus in the middle and they have shells. So usually first shell can have accommodate up to 2 electrons. Second shell can accommodate up to 8 electrons. So if you take an atom, now let's take this one. Lithium, okay, it has 2,1 electron configuration. It has 3 electrons, 2 electrons in the first shell, another electron in the second shell. Beryllium has 2,2. So boron has 2,3, 5 electrons, 2 and 3. Carbon has 2,4. Nitrogen has 2,5. Oxygen has 2,6. Fluorine has 2,7. Neon has 2,8. Now in the second shell, we know that in the second shell, they need up to 8 electrons. So obviously this like the lithium is like the first situation. He has 1 electron, can't like to go to like 8 electron in the second shell, you need 7 more. Obviously lithium knows that he can't get 7 more. He said like, okay, I don't need to 7 more. If someone asks for 1, I'll give it. So therefore this lithium need to lose 1. Beryllium, okay, it has 2. It should take 6 more to go for that 8. So taking 6 is a little bit difficult. No? Says, okay, I will give someone if someone asks to. Boron will do the same thing. Taking 5 is like hard, so I'll give the 3 what I have if someone asks for it. If you get same, if you go for like this fluorine is 2,7. You need 1 more. So obviously, try to get 1 from someone else. Fluorine try to get 1. Oxygen has 6. It need 2 more, like very close. It will try to get 2. Nitrogen has 5. It need 3 more. It will try to get 3. Carbon, it's in the middle. It has 4, just like this situation. Each has 5 rupees. Now, when you have 5 rupees, you are not going to give it because you have that. You feel that I can go for it. So then in that case, you will always go for sharing. Because ionic bonding means if you give electrons and gain electrons, we call it ionic bond. So formation of an ionic bond may depends on one should give electron, other one should gain electron. So lithium, beryllium, boron, these three will try to give electrons. Nitrogen, oxygen, fluorine, these three try to gain electrons. So between them, you can have ionic bond. But carbon will never go for it. Why is that? It has 4, almost in the middle. Like if I can go, like I can't take 4 more, I can't give my 4 electrons out. So obviously carbon will go for the sharing option. So that's why carbon cannot form ionic bonds. So that's the reason. So if you ask in the chemistry, they say that someone, so when you are in the middle, others, they don't have enough power to remove 4 electrons from carbon. So we call it the other, there's no other atom which has enough power, the word power, we call enough electronegativity to remove 4 electrons from carbon. So another person can say that carbon can't even take 4 electrons from others. So carbon does not have enough power to take 4 electrons from others. We call it carbon electronegativity is not enough to gain 4 electrons. So because of that, carbon always go for the like option of sharing, just like this one.
Wow.
I think you got the answer to it. Like, is it clear? That's Lolita, right? Yeah. Lolita?
Yes, sir.
You have given more than information, I think. Yes, Vachita, do you have any question?
Yes, sir. Hello, sir. I'm Vachita. I'm studying 9th grade. My hobbies are reading books and playing games. Can I ask my question?
Yes, sir. Yeah.
Why
Sure.
Mendeleev had to leave certain blank spaces in his periodic table?
Okay. Okay, I'll explain you that one. Vashita, why Mendeleev had to leave some space. Right. Why Mendeleev had to leave certain blank space in his period table. Now, this is the thing. Now, you know that when you go to your school, let's say your principal is angry. So, principal is angry. So, let's assume you did something bad. So, principal 100% sure that you did it. You have a doubt whether your principal has like telepathy. So, he obviously tell that I know you did it this one, right? So if you have done it, he'll for sure he will tell that you have done it. I know it. Then you have a doubt. The reason is now in your school, I think usually in Sri Lankan school, there are like around 3,000 to 3,000 students. In one school, there are 3,000 students. But the principal knows whether you have done it or not. That means principal can remember each and every student. That's a weird situation, right? Actually, he can't remember each and every student. So what will happen is he has groups. Okay, let's assume we have a student called Madhuri. And she's an excellent student. So he just say, okay, excellent group, Madhuri is there. He just have boxes. He has boxes. Excellent box, very good box, good box, and average box. Right. So he has like boxes, then he have like, you know, that he might have very bad. Those times also might be here there. So I'm just talking about the other part, right? So he has all these things now. Okay, then what will happen now? Varshita comes. Now his principal's principal first time sees Varshita. Okay, he said like, okay, Varshita belongs to. He said Varshita belongs to Madhuri's box. That means he said, okay, Varshita is like Madhuri. Then he imagine all the features of Madhuri. Madhuri is like one of the students who was like senior to you. She might be in grade 13 or something because principal knows Madhuri for like almost 13 years. Now when Varshita comes, okay, principal Madhuri likes Varshita. It's just like they have the same feature, but Varshita and Madhuri that are the same person, right? Principal says, okay, Varshita also excellent student like Madhuri. Now when it comes, now let's assume there was something happened. So someone broke a window in the school. Then what will happen? Principal, okay, your prefix, the prefix of the teacher takes Varshita to the principal. So what is the first thing principal says that, okay, check which group Varshita is there. Varshita is in the excellent students group. So obviously principal decide, no, she hasn't done it. So he will say that, no, Varshita hasn't done it. It should be someone else. Just check it. Same way, what will happen? Mendeleev also start classifying atoms. He said like, okay, good, excellent, good, very good, good, average. Likewise, he just categorized them. Then let's assume that, okay, Varashita came. Then after some time, let's assume after Varashita, now principal finds Neerja. Okay, if our principal finds that, okay, Neerja is a very good student. So principal says that, okay, Neerja is good. So he finds, okay, Neerja is in this box. He's a very good student. Okay, let's take another student come. Let's take student we'll call okay, my name. We'll take fire. Okay, no one comes. Okay, principal says that no one is average student. Okay, I'll put no one here. No, then you might argue, no, principal sir has to put them in order, no. So if Varshita in the excellent box, Neerja in the very good box, no one has to be here, no. Why principal sir moved no one into this one? Because principal knows that he is going to put them under with their categories. If no one is not a good student, you can't put no one in the good student. You just keep it blank. Till I find a good student, I will keep this one blank. So the same way, this happens in the period table. So when Mendeleev categorizing, he saw that, okay, when I take lithium, sodium has the same behavior like lithium. So I put sodium below that. Potassium has the same behavior like sodium. He put them together. Why he put them? Just like categorizing. Just like excellent, very good, good, average, he classified them. So let's assume for groups, and he said this one is group 1. It is group 1. Then group 2. Then group 3, when he's going to put it, okay, after he found a metal. Let's say boron. Aluminium has the same property as boron. Then he found that titanium does not have the properties close to group 3. It has the properties very close to group 4. So obviously what he said, till I find someone who has the same property as aluminium, I'll keep this box empty. So therefore, I'm going to put it here. So same way, till your principal finds someone good, he will keep this box empty. One will be end up in the average box. So sometimes because he saw that the elements or atoms with the same properties should line in the same line. So when you don't find the property, he just keep it empty. That's the reason. Is it clear, Varshita? Is it clear though?
Yes, sir. Thanks for clarifying my doubt.
So next. Jagadish, it's your turn.
Yes, sir. Hi, sir. My name is Gattu Jagdish. My hobbies are reading books, playing games, and watching TV. My future ambition is to become an army person. Can I ask one question?
Yes, sir. Yes, definitely.
What is lanthanide contraction?
Okay. Very good question, Jagdish. So you are asking why I will share my screen, no? I'll share my screen. So he's asking, this is the question he has. So Jagdish has this question. He's asking, why lanthanide and actinide placed separately at the bottom of the periodic table? That's a good question. Now, actually, no need to put them in the separately in the bottom of the periodic table, but there's a problem. Now, for an example, let's assume that in your house, let's assume you have chair. Okay, if you take a chair, so when someone enters your house, so they keep chair in front of the house. Obviously, it might be in front of the house. As soon as a person enters, people, your mother and father, will keep the chair in front of the house. But let's say, have you seen hammock? So there's a one called hammock. So when you do agricultural things, you have hammock, something like this. So when you want to prepare the land, you have hammock. So have you seen anyone keep hammock in front of the house? Usually hammock comes like at the back of the house. If you're not agricultural house, but hammock is there. Most of the houses, they have hammock, but like hammock is in the back of the house. Why is that? We never use them. We never use them oftenly, right? So what will happen? You can, if you want, you can keep the hammock in front of your house. But usually, since we are not using them oftenly, you can keep it a little bit aside. So same thing. You can put lanthanide and actinide series in the period table. This is how it happens if you put it. So your period table is a very long one. It's just like in your living room, you have the hammock, chair, and everything. Then you realize that usually in the school chemistry and all those stuff, one is this will be very long. Second thing is it's really hard to use a long period table. Second thing is since we are not using them much because lanthanide are very rare elements. So it's very rare to find it. So what we do is we just say that lanthanide and actinide is supposed to be here, but we are going to write them a little bit bottom. If anyone wants it, can refer to reading. Because then what will happen? The huge length of the period table decrease. Can you see that? This much length is decreased. Then you don't need to know like huge wall or huge page to find the period table. And all the things that which are compulsory, you can focus them on very easily. That's why lanthanide and actinide series come below the normal original periodic table. Is it clear, Jagdish?
Yes, sir.
Jagdish, I think you got the. Okay, good. Okay, sir.
Nagalakshmi, it's your turn.
Yes, sir. Hello, sir. My name is Nagalakshmi. I'm studying in 7th grade. My hobbies are reading books and playing games. My future ambition is to become an English teacher. Can I ask one question, sir?
Yes, daughter, please. Yeah.
How carbon atom gets energy to excite its electron?
Okay. Right. This is Nagalakshmi, the answer for your question. So you're asking how carbon atom gets energy to excite. I think you're asking about something like this. Right. How carbon atom gets energy to excite its electron. So that means you're asking that sometimes when carbon wants to form bonds, so what will happen? Exciting means something like this. Since the others are also listening, so there's we know that in an atom they have nucleus. We have nucleus here, and we have electrons on energy levels. We have energy levels. Even though I draw it like circles, they are actually 3D things, right? But let's assume there's electron. Now she's asking how this electron can go to another energy level, which is up. So usually you can send the electron up into another energy level by using energy. So usually the energy that we have is you can use energy. The main one energy that we know is heat energy. Now you have a doubt. How carbon atom gets energy excited because we don't have heat energy. We do. Actually, if you take our room temperature, let's assume, I think in India also room temperature might be close to 25 or a little bit above that. Let's assume it's 25 degrees Celsius. Now your room temperature is 25, which means in Kelvin it's 298 Kelvin. So let's assume 298 means from 0, it became 1 Kelvin, then became 2 Kelvin, 3, 4, 5, 6, 7, 8, like that. It went up to 298. That means we already have enough energy. But you don't feel it because you're used to it. So that means it's already enough heat energy is there. So that energy can be used for carbon to go for an excited state. And if that carbon going to perform a reaction, so obviously we know that when a reaction takes place, they also produce heat. That heat also can be used to excite this electron into a high energy level. So you can heat it, but at the moment, whatever the energy we have, that's also enough for 1 or 2 carbon atom. It might be huge. But when that 1 or 2 carbon atom excite the electron and perform a reaction or form a bond, what will happen? Then you get more and more energy. That's how it happens. Nagalakshi, is it clear though, your problem?
Yes, sir. Thank you, sir.
Nagalakshmi, it's your turn.
Yes, sir. Hi, sir. Hello, sir. My name is Vedasri. I'm studying in 9th grade. Can I ask one question, sir?
Yes, please, sir. Yeah, definitely.
All alcoholic metals are solids, but hydrogen is a gas with diametric molecule. Do you justify the inclusion of hydrogen in first group with alcoholic metals?
Okay, that's a good question. Don't I also have the same problem when I'm learning chemistry? It's something like this. Let's go for your school principal again. Now, in that, your question says that all alkali metals are solids, but hydrogen is a gas with diatomic molecule. Do you justify the inclusion of hydrogen in the first group with alkali metals? Yes. This is the thing. Now, can you remember that example? We say that, okay, your principal has boxes in his head. Okay, excellent, very good, good, average. Let's take Madhuri in the excellent group, Rajesh in very good, Lakshmi is good, and Shankar is in average group. Now, what will happen? Then a new student come to your school. His name is Mike. Now, principal sees that Mike is the first in the class. He is first in the class. He's the school captain. He's the best in sports also. In the best in the school, like if you take cricket, I think in India, yes, cricket is one of the favorite things. So he's best in sports. He's best in sports also. But he violate all the school rules. My goodness. Now principal has a doubt whether to put him excellent. He should put him because he's first in the class, school captain, best in sport, everything. But he violates all school rules. He can't even put him excellent, very good, good, average. Same thing happened with hydrogen. So this is hydrogen. That's why you ask me why this hydrogen behaves with. So our hydrogen is like Mike. So when this happens once in a while, after once in 10 years, your principal get a student like this. Then what will happen? Principal has very good, good, average, bad, all these boxes. For Mike, he make a special box. He said that Mike is one of a kind. So I should put him in a different place because there is nobody you can find like Mike. So the same thing happened for us. We assume first hydrogen is like alkali metal, like a good student. Then we assume the hydrogen starts showing some bad things. Okay, then hydrogen is a halogen. We put in the other one. Then hydrogen is still again behaving like alkali metal. So what we do is we put a special box. If you take the modern periodic table, you can say that these ones are in the group. Hydrogen is in a corner, somewhere isolated, just like this mic box, which your principal has in his head. So at the moment, actually in the modern periodic table, hydrogen is apart from neither from alkali metal, neither from halogens. It's categorized as a separate box because its properties are one of a kind. Right. Is it clear to Veda? Is it clear, Veda?
Yes, sir. Yes, sir. Thank you, sir.
Welcome.
Kaushik, it's your turn.
Hello, sir. My name is Kaushik. My hobbies are reading books, playing games, and watching TV. My future ambition is to become a police officer. Can I ask one question, sir?
Yes, sir. Please. Yeah, you can ask.
Why noble gases don't participate in chemical bonding?
All right. Very good question, Kaushik. So why noble gases don't take part in the chemical bonding? Right. This is the thing. Now, we discussed that if you take energy levels, all of them want to have a complete outermost shell. Like first shell has 2 electrons, second shell has 8 electrons, third shell has 80 electrons. But if you have already everything, now why Kaushik you have different dreams? Because you have to fulfill something. Because you have to feel something. If you are feel, now let's take you became a police officer. Let's say you became the DIG of the country. Then after that, nothing to feel now. So the same way after you become DIG, you say that okay, I don't want to become anything else because I just achieved my dream. So same way, Neon already has completely outermost shell. So Neon said that no need anything else after that. So when you become DIG, I think yeah, DIG or DCP. I think in India they call DCP, right? So when you become the top in the police, you say that I am satisfied. So same way, these noble gases, they are already have the completely outer field, outermost shell. So they say that no need anything else. So they don't go for formation of bond. Is it clear, son?
Yeah.
Kaushik?
Yes, sir. Thank you, sir.
Yeah, Hamza?
Still, I think Navya. Navya, do you have any questions for start?
Sir.
So, do you have any questions?
Yes, sir.
Yeah, please go ahead and ask.
Hello, sir. I'm studying 10th grade. Can I ask you a question?
Yes, do it. Yes, please.
Why alcohol and glucose do not show acidic character though they include hydrogen?
Sorry, alcohol and glucose do not show acidic
acidic
character, even though they
though
show they
though they
contain
include hydrogen.
Okay, so it's a very good question. Yeah, okay, right. Okay, I'll just explain that part. Now, if you take alcohol and glucose together, right?
Yeah.
All right, okay. So if you take alcohol and glucose too, I think I'm still sharing the. Can you see me the? Can you see the screen? Uh, I didn't share the
Yeah.
screen. No, okay. All right, okay. Now you can see it. Okay. Now, if you take alcohol and glucose, they all both have hydrogen. Yes, if you take glucose is C6H12O6. Alcohol is C2H5OH. Now they are asking why don't they, even though they have hydrogen, why they are not showing acidic properties? For an example, let's take in India. So we have Mukesh Ambani in my okay. I think he's the richest person in India, right? I don't know whether rank has changed. He's the richest person in India. So let's assume there's another person in India. So let's very rich person. I'll call it Rocks. This person also there. So let's assume people say that Mukesh Ambani is a very good person. Because people say that he's a very good person, he donates. So because he donates, people say that he's a good person. So because he donates, he has money. So he has money and he donates his money for charity. Let's take this person, Rocks. That's also from Indian, like one of the richest. But let's say this is the first richest, and he's also the first. They are also having the same amount of wealth. Let's assume Rocks also have money, has money, but let's say he doesn't give, he doesn't donate. No donation. If you go there, he will chase you out. Then he asks, why he's not a good person? Why your richest person, this person is good? Why this person is bad? Even though he has money, he doesn't donate, he doesn't help other people. So same way, to become an acid, having hydrogen is not enough. You should have hydrogen as well as you should give it to others. You should donate hydrogen. If you take glucose and ethanol, even though they have hydrogen, they don't have a way of donating it. So therefore, this one do not donate H plus science. This one do not donate H plus science. So therefore, these are not an acid. But if you take HCl, we call it HCl an acid. Because what is the rate? HCl gives H plus science. If some other molecule asks for H plus science, HCl gives. So therefore, we call HCl is an acid. Is it clear though? Did you get the idea? Is it clear enough?
Yes, sir.
Okay.
Sir, can I ask another question?
Yes, okay. Yes, another one.
Sir, could you please explain the electronic configuration of chromium and copper?
Chromium and copper. Hari, I think I'm going to explain. Are we going to log off and join again? Are you muted?
So Navin,
Sorry? Sorry, Hari. So shall I explain it? I'll try to explain it. I don't know like whether they have.
try to explain.
Okay. Okay, I'll try to explain. So if I switch off, so sorry about it. So she's asking chromium and copper electronic configuration. Okay. So if you take this one, let's take, if you take chromium, I'll go really fast, so, and copper. If you take chromium electron configuration, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. That's the electron configuration of chromium. Right. It's something like this. Let's assume that you go on a trip. When you go on a trip, let's assume that there are rooms. So we know that there are rooms, right? So let's assume you go on a trip, there are 6 rooms, and there is only 6 of them, 6 of you. That means let's assume you have 6 rooms, 6 people. Are you going to sleep with your friend in the room? Are you going to share the room? No need, right? Now you go to a hotel. The hotel has 6 rooms. Why you are going to share with you? So obviously sharing one room between each other, always there will be a repulsion. So there will be a repulsion. So these are electrons. We know the electrons are negatively charged. So since they repel each other, so let's assume in your room there's another one here. So obviously what you say that, see, there's an empty room. Just go there. So you can stay there. Don't come into my one. So you will chase that one here. So therefore, actually, the chromium electron configuration will be, it's the same thing, 1s2, 2s2, 2p6, 3s2, 3p6. Now it becomes 3d5, 4s1. Same if you go for copper, it's 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2. Here what will happen? For D subshell having completely filled outermost shell is stable. 1, 2, 3, 4, 5.
Luan, sorry to interrupt you.
Yes,
we have no time is left. So let me ask my student. And again, do you have any more questions still?
No, sir.
So okay, and Luan, I think another.
Yeah, definitely.
Time I request you to right now. So anytime with you.
Okay, that's definitely fine. Yeah, you can schedule another one and you can inform.